Have you ever noticed that airplane windows are always round? If you look closely at almost any commercial airplane, you will see that the windows are not square or rectangular. Instead, they all have smooth, rounded edges. At first glance, this might seem like a simple design choice. Maybe it just looks better. Maybe engineers preferred the shape. But the real reason airplane windows are round has nothing to do with style. It actually has everything to do with safety. In fact, the shape of airplane windows was changed because of several catastrophic accidents in the early days of aviation. And those accidents taught engineers a very important lesson about pressure, metal, and the dangers of sharp corners. To understand why airplane windows must be round, we first need to understand what happens when a plane flies at high altitude. Most commercial airplanes cruise at an altitude of around 35,000 feet. At that height, the air outside the aircraft is extremely thin and cold. The temperature can drop to minus 50 degrees Celsius, and there is far less oxygen available to breathe. Humans cannot survive in that environment without protection. That is why airplanes use something called cabin pressurization. Inside the cabin, the air pressure is increased so that passengers can breathe normally and remain comfortable during the flight. But this creates a big difference between the pressure inside the airplane and the pressure outside. The aircraft is essentially acting like a pressurized container, and every part of that container is under constant stress. The fuselage, which is the main body of the airplane, expands slightly every time the cabin is pressurized. When the plane lands, the pressure decreases again. This process happens on every single flight. Over time, that repeated expansion and contraction puts stress on the aircraft's structure. In the early days of commercial aviation during the 1950s, some airplanes were designed with square windows. At the time, engineers believed square windows would maximize the viewing area for passengers. However, they soon discovered a serious problem. Sharp corners create something called stress concentration. When pressure pushes against a surface, the stress is not distributed evenly around sharp corners. Instead, the force builds up in those areas. Think about bending a piece of paper. If the edge is smooth, the pressure spreads evenly. But if there is a sharp cut or corner, that spot becomes much weaker and more likely to tear. The same principle applies to metal structures like airplane fuselages. During repeated pressurization cycles, tiny cracks began forming around the corners of square windows. At first, these cracks were very small and difficult to detect, but over time, they grew larger. Eventually, several aircraft experienced sudden structural failures while flying at high altitude. One of the most famous examples involved the de Havilland Comet, one of the world's first commercial jet airliners. Investigations revealed that the square windows played a major role in the accidents. The stress concentrated at the corners caused the metal to weaken and crack. Once engineers understood the problem, the solution became clear. The windows needed to be round. Rounded shapes distribute pressure much more evenly across the structure. Without sharp corners, stress cannot build up in a single point. Instead, it spreads smoothly around the edges of the window. This dramatically reduces the risk of cracks forming in the aircraft's fuselage. That is why modern airplanes always use oval or rounded windows. The shape helps maintain the structural strength of the aircraft even after thousands of flights. Today, aircraft engineers carefully design every opening in the fuselage, including doors, hatches, and windows, to minimize stress concentrations. Even small design details can have a huge impact on safety when dealing with pressurized aircraft structures. So the next time you sit next to an airplane window and look out at the clouds, take a moment to notice its shape. That smooth, rounded frame is not just a design choice. It is the result of decades of engineering lessons and improvements in aviation safety. And thanks to that simple but critical design change, modern airplanes are far safer and more reliable than ever before. Sometimes, the smallest details in engineering make the biggest difference.